Hi everyone, I'm Anmol Agarwal. Today I'll be presenting our work Learning to Automate Follow-up Question Generation using process knowledge for depression triage on Reddit posts. This is joint work between the researchers at Precog Lab at IIIT Hyderabad in India and the AI Institute at University of Southern Carolina. We thank the committee of CLPsych and NAACL for this opportunity. When a patient generally visits the doctor's office, the conversation usually starts with the patient providing a short description of their symptoms. Some such examples are: I'm feeling down and depressed, my fatigue is unbearable, I cry several times a day. In such a scenario, in a real life clinical setting, the doctor will usually ask follow up questions to the patient, such as how serious are your symptoms, or what is the frequency with which symptom XYZ is occurring, and so on, in order to gain diagnostically relevant information about the patient's condition. Some examples of follow up questions taken from PHQ-9, which is the patient health questionnaire specific to depression, include: how many hours of sleep do you get on average each night? Have you noticed any appetite changes in response to your mood? Influenced by this system, in the context of depression, our aim is to basically design a model such that the input to the model would be a help or support seeking post from Reddit where the user talks about their experience with depression. And the model output would be generation of follow up questions which are safe, coherent, diagnostically relevant, and information seeking in nature. In order to test our approach, we curated a dataset of 21,000 posts and their comments from the Depression Help subreddit from Reddit, where users generally share their experience and advice in the context of depression. In order to retain only the advice seeking posts, we kept only those posts which had the flare tags seeking help and seeking advice. We also removed those posts which did not have any interrogative statements and questions from the users in their comments. On applying these filters, we were left with just 2003 posts. Here is a post which we'll treat as a running example for the remaining presentation. On the left is the post content where the user talks about his symptoms such as unbearable fatigue, dull senses, dry eyes, feeling drunk, and needing lots of sleep. On the right are the questions asked by Reddit users in the comments for that post. Qualitatively, one can see that the questions like does the fatigue wax and wane or have you had your iron levels checked are very specific and relevant to the user's post. One of the questions asked is: are there any autoimmune diseases in your family? Now, in order to ask such a type of question, the person asking the question would need to have knowledge of whether autoimmune diseases fit the mentioned symptoms at all and would also have to know that some autoimmune diseases are genetic in nature. With the hopes of asking similar quality questions as the Reddit users, we use three deep learning question generation models. Model 1 is simply an off the bench T5 model fine tuned on the Squad 2.0 dataset. Model 2 is obtained after fine tuning Model 1 on a dataset containing these Reddit posts and the interrogative sentences asked by the Reddit users in the comments to the posts. We noticed that some of the questions asked by Reddit users in comments were post context specific. For example, can you use Microsoft Excel or did you even read the complete post? Are interrogative in nature but still not diagnostically relevant. In order to remove such questions, we filtered out those interrogative comments whose best blurred score with any of the 143 questions in PHQ-9 fell below a threshold value. Model 3 was fine tuned using extended PHQ-9 on this filtered dataset. Since DLMs generally have a limitation on the number of tokens which they can receive as input, we had to chunk the post into several parts, with each part having less than 512 tokens. In order to measure the quality of the questions generated by the models, we use the blurred similarity metric. Since the 9 questions in PHQ-9 are not diverse enough for fine-tuning and similarity-based performance measurement, we extended the size of PHQ-9 with the help from workers at the National Institute of Mental Health and Neurosciences to a total of 143 questions. Though this set is still not exhaustive, we believe that these 143 questions serve as a very good seed set, broadly covering many aspects of depression and anxiety. On qualitatively judging the questions generated by the three deep learning models, we observed that most of the generated questions were unsafe and had objectionable language, were incoherent and grammatically inept, diagnostically irrelevant, and were redundant as their answers could already be inferred from the content present in the user post. On the left is the same post which we had seen earlier, where the user talks about his experience with depression. On the right are the questions generated by deep language models. Let's look at the questions slightly in detail. Question 1 asks, what has caused the gradual cognitive decline? Now, such a question needs to be answered by the clinician and not by the patient. In the post, the user has already mentioned that he has tried antidepressants and has already seen a therapist. As a result, generated questions 2, which is are you on any antidepressants, and question 5, which is are you seeing a therapist, are redundant and would not reveal any new information from the user. Questions 3 and 4, are you aware of the qualities of antidepressants and what do antidepressants work at, aim to know how much the user knows about antidepressants, which is unlikely to affect the final diagnosis. Questions 6 and 7 are incoherent, poor attempts at paraphrasing the sentences in user post. Question 10 is inappropriate as it has objectionable language. On qualitatively comparing the performance within the three models, we notice that the fine tuned models 2 and 3 generate more inquisitive questions, which can be attributed as an after effect of training on Reddit. For example, one of the Model 1 question generations is, did doctors know how much of what was the genetic problem in my health? Such a question is grammatically incoherent and a poor attempt at paraphrasing one of the questions already present in the user post. On the contrary, answers to questions by models 2 and 3, such as have you considered going to the school to prevent you from getting tired, or have you used any antidepressants, can have potential for extracting new information on the user's health condition. However, we also notice that the grammar of questions generated by Model 1 is much better in general than those generated by Models 2 and 3. We suspect that this may be due to the fact that Models 2 and 3 were fine tuned on crude, informal nature of sentences used by Reddit users. To measure the quantitative results of the generated questions, we calculate the hit rate of a chunk by measuring the blurred similarity of the set of generated questions Q had with the questions in extended PHQ9. For a generated question, we define its score as the maximum blurred similarity which that question had with any of the 143 questions in extended PHQ9. If this score exceeds a certain fixed threshold, we count the generated question as a hit, else we count it as a miss. For each of our three models, we calculated the hit rate by varying the number of generated questions per chunk of a post and also by varying the threshold delta which we apply in order to classify a generated question as a hit or a miss. From the table, we observe that Model 3, which was fine tuned on Reddit data filtered using PHQ9, performs the best across all thresholds, which implies that the model positively responds to the knowledge infusion process using PHQ9. To build on our work and to prevent redundant question generation, we propose a two-step pipeline. In step 1, we try to detect for which questions in PHQ9 the answers can already be inferred from the initial user post. Questions which already have an answer will be redundant if asked again. In step 2, it is possible to use these questions whose answers are not already present in the post to guide generative DLMs by leveraging the DSM-5 lexicons and other sources of external knowledge. In order to achieve step 1 of the pipeline, we curated a new dataset called Primate. Primate has 2003 Reddit posts from the Depression Help subreddit and has three main attributes: post title, post text, and annotations regarding whether the 9 questions in PHQ9 are already answerable using the user text. For example, in this post, the user mentions that he struggles to make himself leave the bed, which helps us to know that the user sleeps too much, and hence, question 9 is already answerable using the user post. On the other hand, the user makes no mention of his concentration, and hence, one cannot be sure whether the user has concentration issues or not. Hence, the annotation for question 8 is no. In order to measure the effectiveness of Primate in helping evaluate answerability, we used it to train 9 BERT classifiers, one for each question in PHQ9, with the output being yes if the question is already answerable using the post content and no otherwise. In order to make up for the class imbalance in the dataset, we use Matthews correlation coefficient to measure performance. The classifier is able to obtain a score above zero point 0.4 for questions 2, 5, and 7, meaning that the model's judgment can be reliably tested for these questions. For questions 3 and 9, the score is between zero point 0.3 and zero point 0.4, meaning that the model's judgment is moderately reliable for these questions. For questions 1, 4, 6, and 8, the score is less than zero point 0.3, meaning that the model is unable to pick the necessary cues to reliably evaluate answerability for these questions. For our work, we acknowledge partial support from the National Science Foundation. We also thank the annotators and professionals from the National Institute of Mental Health and Neuroscience for their contribution in the dataset creation. We also thank CLPsych and the ACL committee chairs for granting us a scholarship to publish this paper. We as authors hope that our proposed system and the dataset could play a meaningful role in clinical triage at large healthcare or internet delivered care settings and may strongly interest clinicians and healthcare organizations. Thank you for listening to our presentation. We'll be glad to answer any questions.